It's a random graph. What is happening each time our graph switches from increasing to decreasing?
Critical numbers, critical point, zero.
Okay. Any other words that we've talked about in the past few days?
Absolute, you have relative minima and maximum. So it's absolute.
So each of these three coordinates where we switch from increasing to decreasing are what?
Relative maximums.
Relative maximums. Okay? What happens when we switch from decreasing to increasing?
Relative minimums.
Oh, we have relative minimums. Welcome to the first derivative test. Okay? So don't write this down. But we have these critical values, right? We have some critical points. Okay? Our critical points are potential mins and maxes. Okay? Some critical points are nothing. Some critical points are relative minimums. Some critical points are relative maximums. If our derivative changes from negative to positive, that means our function changes from decreasing to increasing. We have a relative minimum. This is the first derivative test. Okay, so you identified that if we go from decreasing to increasing, there's a relative minimum there. Okay, let's think about that in terms of the first derivative. If our first derivative switches from negative to positive, that means our function is going from decreasing to increasing. We have a relative minimum. What is the first derivative test going to say about a relative maximum? Okay. We know we have a relative maximum if our function goes from increasing to decreasing. So if our derivative changes from positive to negative, then we know our function is changing from increasing to decreasing, and we have a relative maximum at our critical point. Yes.
Without looking at a graph,
Okay. There are some critical points that will not be a relative minimum or maximum.
Why is it a music symbol?
No.
Okay, that's
To some people it is fun too. Okay, so note, if there is no sign change, then our critical point is not a minimum or a maximum. Okay. We have critical points when the derivative is 0 or undefined. So it's possible that we talked about yesterday where we can increase and then kind of flatten out and then keep increasing. Okay. Here we're going to get a critical point, but we don't have change in direction, and so it's not going to be a relative extreme. Do you have a question?
Yeah. What about for like absolute? Where's the absolute maximum and absolute minimum? Because what could happen is I can have like from a meter go negative 44. I can have happening as an absolute. So what would be the absolute?
So we wouldn't have a minimum or maximum at a value that would make our original function undefined. okay? So does that make sense? If we have a rational function, so he's asking about an asymptote, okay? Where that asymptote is going to be one of our critical points, but if it's not in the domain of our function, it can't be.
Well, I'm just saying if it is.
Well, an asymptote wouldn't be in the domain.
Because finding in the domain, like in the domain A44, right? Or did I miss it?
Well, if there's an asymptote in the original function, that value is not in your original domain. Because it makes your fraction undefined. That's why there's an asymptote.
No, I'm not saying the original. I'm saying the original.
Well, then if there isn't an asymptote, our relative, so that's going to give us a critical number, okay? But if that's not where there's an asymptote in the original function, we're going to be able to find an actual value, okay? So these relative minimums and maximums, we're going to get the y coordinate from the original function, like you did on Friday. Okay, so first, let's start out with what we did yesterday. Here's a function. This sounds familiar? Did we do this one yesterday? Okay, so if we want to know increasing and decreasing intervals, what do? Okay, derivative. So when you see increasing or decreasing in your head, you need to think derivative. What is the derivative? And when we set that equal to 0, what are our critical points? And then we make a number line. To the left of -2, what's going to be the value of our derivative? So what do you want to pick? -3. So 3 times 9 minus 12. Okay. How about between -2 and 2? When we plug in 0, our derivative is? And then beyond 2, positive. We did do this one yesterday, didn't we?
Yeah.
I'm not making things up. Okay. So we are increasing where? Okay. Here's an important thing, idea. I don't know. Justify. If I ask you to justify that these are our increasing intervals,
Sure, realize positive or negative.
okay, because f prime of x is positive. Okay, we are decreasing from -2 to 2. If I asked you to justify that, you would tell me. Okay. Now, that's what we did yesterday. Let's move to the first derivative test. Yes.
What if when you plug in a number at 0?
Then that means your derivative is constant and it's neither increasing nor decreasing.
So what would you like right
That it would be constant on this interval because the derivative is 0. Does that make sense? Okay. So now determine the x values of any local maximums or local minimums. Justify. Okay? So now we've done our work with the first derivative. Let's go to the sign chart. What's happening at -2? Our derivative is changing from positive to negative. So we have a, so x equals -2 is a relative maximum. Why? What's it? I don't know what it is. Okay. Because the derivative is changing from positive to negative. A sign chart is not justification. You have to tell me about it. Okay? What's happening here at 2? And why do we have a relative minimum, John? That is exactly what's happening. So x equals 2 is a relative minimum because well, it's because f prime of x is changing from negative to positive. Yes, that's it. That's the only thing. Okay?
I feel like that's sarcastic.
Hence why we need.
Sarcastic.
3 more.
I just thought it was sarcastic.
No, that's we're gonna look at like graphs and what they mean. Like we're gonna look at a graph of a function and identify mins and maxes. We're gonna look at the graph of the derivative and identify mins and maxes. So really, I mean, we're just adding on one simple thing. Okay? And one extra step. Okay? Josh? Okay.
So, that's basically the,
First derivative test.
yes, but it's the x. The something with the x axis or cross the x.
On the derivative.
Yeah.
Yes. Okay, find the relative extrema. So if we're going to use the first derivative test, we need the first derivative. Okay, so help me out.
That would be like also be a relative maximum at the same time, because like you have say you have two largest. One is higher up than the other, but can they both be relative maximums? So only this one can be absolute maximum because it's highest, or
Like this?
Yeah, something like that.
Yeah, those would both be relative max.
But only the taller one would be the absolute maximum.
Right. And we're only going to worry about absolute when it is.
Right.
Okay. All right. So we have 2/3 x squared minus 4 to the okay. So we have 4x over 3 times x squared minus 4 to the 1/3. That's how you'd want to rewrite it. Critical values. 0 because that's where our numerator is 0. Plus or minus 2 because that's where our denominator is 0. So 0 is where our derivative is 0.
Oh.
Oh, that's the one from yesterday, which was a 9.
Okay. Okay. So how about you take 30 seconds to fill out the sign chart. I'm going to refer to this as a sign chart. Excellent. Hang tight. All right, Nathan.
Negative, positive, negative, positive.
Agree or disagree?
I agree.
Okay, so I'll plug in. So if you plug in one there, you have the answer.
Yeah.
Right. All right. Yeah, you're right.
Good catch, Nathan, thank you. Okay. So now, what's happening here?
Relative minimum.
What's happening here? And what's happening here? Okay, so I want the actual coordinates of these. So we have relative minimum at -2, comma,
According to the original.
yes,
0.
0, and 2, comma, 0. Okay, I'm not going to write out the justification, but why are these minimums?
Because the derivative goes from the negative to the positive.
Okay, very good. John was mumbling it, just mumble it louder.
Doesn't it have to be with you?
Because those aren't intervals, those are coordinates. X, Y coordinates. Okay, mins and maxes will always be coordinates. Okay. Relative maximum at 0.
Negative 2.5 to 0.
Okay, let's talk about this. So 0 minus 4 to the 2/3
So negative,
means
negative 4.
the cubed root of 16. And this is a relative max because the derivative is changing from
Positive to negative.
excellent. Okay, one more algebraic example.
Are the relative minimums always going to have a lot of value?
No. This was just kind of nice.
So relative extrema is like
Yes,
some laws.
yes.
Why is it called extrema?
Yeah, because we're going, like, they're extreme.
Oh,
Yes,
Can you go back?
yes.
How did you get the like 0, 0 and the cube root of 16? Where did those come from?
We plugged the x value into the original function to get the point on the graph. Okay? Sometimes you'll be asked for the x coordinate, sometimes you'll be asked for the coordinate in its entirety. So write this one down. And this isn't actually what I want you to write down. Gosh darn it. Sorry, I'm sorry. I'm sorry. I don't want you to know.
I wanted
You have erasers. This is an easier derivative.
The other one was
Is it really?
4x.
I thought the other one was pretty easy
Dang
too.
it. Okay.
That's something you're recording now.
We're really going back.
No, we're not
No.
going back.
Oh,
I just scribbled it down.
Hey, but she's got an eraser.
The derivative.
Oh, jeez.
One. One minus.
It's expert.
Well, think about it. Yeah, you split the two up, so it's.
Oh, are you splitting it up? Okay. This would be my suggestion. You could take the derivative as a quotient rule. You could take the derivative as two separate values. My only warning to you is that we're going to have to figure out where the derivative is 0 or undefined. So eventually we're going to want it as one big fraction anyway. So you can do it either way.
Wait, the answer is 1 though.
What did you ask over here?
I'm pretty sure it's what? I'm pretty sure.
Quotient rule. Low D high minus high
Oh, I copied it
D
down.
low.
Oh, man. I put x squared plus x over x. Then it would have been 1.
It's still.
It's x squared.
7
minus
was X.
2.
So it would have been 1 because, okay,
Anyway, what's our derivative?
X
It's my third time.
I'm just gonna take a couple seconds for you to focus back,
Chillax.
catch up with me. So now, what do we need to do with this?
Instead of equal to 0. And
Come on.
Oh, here's your favorite part, are you ready?
Yes, they call calculating, right?
Where is the derivative 0?
plus or minus 0. 1.
And where is the derivative undefined? 0. Which is good because what's happening in our original function? That's where we have an asymptote, right? So that should appear as a critical value. Okay. So now we'll make a sign chart with -1, 0, and 1. So if we plug in -2, what?
Use your big boy voice, please.
It would be 4 minus 1 over 4. That would be positive. Okay, how about like -1/2? Well, because -1/2 squared would be 1/4, minus 1 would be -3/4 divided by positive 1/4. Okay, what happens when we plug in a positive 1/2? Oh, it doesn't always go positive, negative, positive, negative? Are you sure?
Yeah.
Did you do something wrong? Okay. And after 1? Positive. Okay, let's talk about what this means. What does this mean? X is -1 is a what? Maximum. What does this mean? Nothing. What does this mean? Okay. So we have a relative maximum at -1 -2, and we have a relative minimum at 1, 2.
Matrix.
I know, it's exciting, right? What was our function? X squared plus 1? Okay, so here is our graph. Okay, we don't have any, we do not have a relative minimum or a relative maximum at x equals 0 because it's an asymptote. It still popped up in our critical numbers, but we can't have a relative min or max there. Okay, here's our maximum at -1, -2 because we're switching from increasing to decreasing. Here's our relative minimum at 1, 2 because we're switching from decreasing to increasing. Okay. Isn't it cool how much we can tell about a graph without actually graphing it? I think it's quite fabulous. Okay. All right. What? Because you're my only calculus class.
Seriously?
Well, I teach calculus BC, but you're my only AB.
Because I thought you were
All
recording some
the
of the previous-
videos are just for us, not
Yeah.
just.
Oh, I thought other people were watching.
I thought it was-
Well, some people from Mr. Griebel's class may come and watch my videos if they're gone.
Or are you the only one that records like
I think you were worse than
Hazelhorse does some flipping, but I don't know what other teachers do, but this is what I do, so if you're gone, you can get caught up without having to come in, like,
Are you recording right now?
yeah. Hello, everybody.
Hello.
Okay. Here is the graph of a derivative, which this is kind of what we started out class with, right? Okay, so now we're going to look at a derivative graph, and I want to know where the relative extrema are, just the x-coordinates, because we don't have any way of knowing the y-coordinates. Zach, you have something you would like to say?
Is it at negative 1, 0, and 1?
No, it's negative.
Okay. Okay, this is the derivative, right? So the zeros of our derivative represent what?
The maximum, minimum of our radius.
Okay, that's where we will have horizontal tangents. Okay? Here, we are going from a derivative being positive to a derivative being negative. What is happening at x equals negative 1?
They're switching. From positive to
Relative
positive,
maximum.
maximum.
Okay? At x equals 0, this is where our derivative is going from negative to positive. What's happening there? And what is happening at x equals 1? Excellent.